Okay folks, so in this example here I want to show you how we can graph a numerical solution in Excel. So in previous videos we've learned how to use either the Runge-Kutta fourth order or in this case the Euler's method in order to approximate solutions numerically. And I'm not going to completely review that, but we'll look at this example to guide us. So here in this example I'm just asking you to graph a numerical solution to this given IVP. Y prime is equal to t plus y, and y of 0 is equal to 3, using Euler's method with a step size of 0.01. So let's go ahead and do that. I'm going to go ahead and pull open Excel here and we'll take a look. Okay, so folks, we saw that we were going to look at the differential equation y prime is equal to t plus y, and that was with the initial condition that y of 0 was equal to 3. So we're going to go ahead and compute a solution to this numerically, just as we've done in earlier videos, using Euler's method in this case. So let's talk about what step we're on. We'll start at the 0th step. I type in 1, I type in 2. Then notice I click and highlight these two cells. Notice I've got that large X cursor. If I pull my cursor down into the lower right corner, I've got the smaller crosshair cursor. If I drag that down, Excel picks up the pattern and puts it and fills in the cells. So then I need to go ahead and look at my t value and my y value. Well, based on our initial conditions, when t was 0, we said that we would have a y value of 3. Now I need to get to my next t value. Well, how am I going to do that? Well, in the problem I said we're going to use a step size of 0.01, so there's my step size. So how do I advance to the next t value? I just go up by a step size of 1. So what am I going to do? Type equals, because I'm giving it a formula. I tell it to use the previous t value, notice it registered cell B2, plus my step size. Okay. As a reminder though, and we saw this in earlier videos, I have to hit F4 on that step size so that when I drag down these cells, Excel doesn't think to then take these values below here. Oops, mistake there. 1 and F4. Great. So notice I started with t value of 0. My next t value is 0.01, and we can run through, and we're increasing each time by taking the previous time value and adding our step size to it. So now we need to come up with the y value. Well, Euler's method says, what do? We take the previous y value, which in this case is cell C2, and we're going to add to that our step size, and I need to lock that in because I want to leave that there, times our derivative, which we're going to denote by the function f, and I'm going to type f of, and then we'll just put 0, or we'll tell it to refer to the time value, the previous time value, plus the comma the previous y value, and we type enter. Notice I've got an error here. It says name. Why is that? It's because I haven't bothered to define the function f yet. So I go up into my developer tab. If you don't have this developer tab, as a reminder, in my first Excel tutorial I showed you how to get that developer tab. We click on the macros. I type f and create. Okay. It defaults to calling it a sub. I'd like to call it a function, so I'll put function, and then I type f of, and then I'm just going to enter in what the variables are, so we'll use t comma y. Okay. Notice it automatically goes ahead and calls that in function, and then we'll just say what f is equivalent to. F is equivalent to, based on our differential equation, we said it was going to be t plus y. And I type enter. At this point I could just close this window, or I could just minimize it. I like to click on File, Close, and Return to Excel. So here we are back on the page where we're entering in this data, and it's still giving me name here, meaning it still hasn't figured out what f is. That's because I have to re-crunch this. So what I'd like to do is click up in this cell, and then when I hit enter, notice it's actually evaluated it. So what did it do? Well, it took the previous y value, as we said it should. It took the previous y value of 3 and added to it 0.01 times our derivative. Well, the derivative is simply the previous t value plus the previous y value, so we get 0 plus 3, or 3. So that gave us 3 plus 3.03. So that worked as we expected, and we can go ahead and run this down a ways. Okay. So we can now generate, that'll be problematic here, let's see here. We can now go ahead and generate some more values for this function. Let's go ahead and take it all the way out to 100 values, so we've looked 1 unit into the future. Okay, or 300 units into the future. That's fine. So I just clicked and drug those down. Now what I'd like to do is actually graph this solution. And so what I'd like to do is to go ahead and insert a graph. And I want to use my t-values as my x-axis, that's my independent axis, and my y-values as my y-axis, my dependent values. So let's go ahead and look at how to put that chart in. What I'm going to do is I'm going to notice I'm going to move my cursor up here, and I'm going to highlight and then click and drag these 2 columns. Okay, so again, I've got my cursor up there. I'm going to click and drag these 2 columns. Now, Excel will automatically assume that the first column I highlighted I want to be my independent axis, and the second column I highlighted I want to be my dependent axis. If you are working with another chart, you might have to specify that, and I'd be happy to help you see how to do that. Now I'm going to go click on Insert, and I'm going to come over here to these charts here, and I'll go ahead and click on that. And let's just take a regular scatter chart. And here we have, it's plotted, down here we've got our time axis. Remember I went out to about 300 time values of increment 0, 1, so I went out to about about time equals 3.5 or so. And you can see that it's got the various y values along here, and so we've graphed this solution curve. Okay. Let's say we want to change our ODE to something a little bit more interesting, so let's change it up here. So let's say we had this ODE, something that looks a little bit more like your homework question. Let's do, we could do y times 5 minus y. For instance, yeah, let's do that. Let's do y times y minus 5. So let's go ahead and change that in our macro. So I go to our developer tab, click on the macro, type in the name that we defined for this function. We called it f. Notice here, instead of hitting create, I don't have that option. I'm going to click on edit. There was the function we typed in, but now I want to do y times parentheses, I think I said 5 minus y. Okay. So I again hit File, Close, Return. And notice nothing's changed in this problem. Well, that's because I had to reevaluate a cell. So let's just come into any old cell, click on it, and then type Enter. And what it did was it went ahead and recalculated this for all values of the function. And here we have something that looks a little bit more like our logistics model. Let's go ahead and say that our initial y value was 1, just this looks a little bit more like the logistics model here. In fact, let's make it 0.1. Great. Now you can see that logistics curve. So that's for the ODE y prime equals y times 5 minus y with the initial time value or initial y value of 0.1. So that's how we go ahead and insert a chart. Let's do that one more time. I'm going to delete the chart just to practice. I'm going to, again, I highlight the 2 columns that I want to use. Excel automatically interprets the first column as the independent and the second column as the dependent. You may want to change that, but I'm fine with that. I'm going to click on Insert, then I click on Charts, and then I click on Scatter, and then we've got a graph of our solution curve. So I'll let you try that in your homework problems. Let me know if you have any questions on this.